Okay, for this one, we are given 3.5 grams of nitrogen triiodide, and they want us to find the grams of iodine. So here we're given grams of a whole compound of nitrogen triiodide, which is Ni3. It's Ni3, not anything with charges and crisscrossing. As soon as we see the prefix tri there, we know we're using that other naming system. So nitrogen triiodide, one nitrogen, three iodines, Ni3. Um, Going from grams of the whole to grams of one part of it. We are not able to multiply by subscripts when we're dealing with grams. Multiplying by subscripts only works for moles to moles or molecules to atoms. So whenever we have grams of the whole, we want grams of the part. The best way to do that is through percent composition. You don't have to find the whole percent composition, but since we want the grams of iodine, we're going to start by finding the percentage of iodine. So Ni3, let's get its molecular weight. There's one nitrogen that has a molecular weight of 14 and three iodines that each have a molecular weight of, I believe, 127. Yep. So 14 plus 3 times 127 gets us a total molecular weight of 395. So the percent that is iodine of that 395, whatever 3 times 127 is, that was what the iodine contributed. So really it's 381 of the 395. That tells me, if I do that division, that it's 0.965 or 96.5 after I multiply by 100% iodine. So 96.5% of my 3.5 grams is iodine. 0.965 times 3.5 will get me my grams of iodine. Which I get 3.38 if I round. Or an alternative way of doing this is, instead of doing what I just boxed in blue there, as soon as you have the ratio set up of molecular weight of all the iodines over total molecular weight, you can look for the grams of iodine by putting it over the 3.5 grams of the total. Mathematically, this ends up being the same thing. We cross multiply to solve for x, and you would also get 3.38.